Hi, and welcome to section 3, Improving Models. In this section, we are going to look at model evaluation, better measures and accuracy, understanding the results, and improving the model. In this video on model evaluation, we are going to look at what are parameters and hyperparameters, what is a test set, what is a validation set, and look at a process called k-fold cross-validation. Let's first talk about parameters and hyperparameters. There are two types of values that are involved during the model learning process. The first one is a set of values that can be learned from the data. Example, the weights and the biases. Another set of values cannot be learned from the data, and this is something the user has to somehow estimate based on different tests, like the learning rate, the number of iterations, the number of features, or the kernel used in SVM. We'll talk about kernels in SVM in the next section. So basically, hyperparameters are the knobs that we can tweak to get an understanding of the data better. One of the main objectives of supervised learning is to make predictions on new data. Let's say this is our initial data, and we divide this data into two parts, training data and test data. Now, as we progress along during the course of this learning, we want to estimate the number of features or the learning rate. Let's say for different number of features, this is the training error and the test error that we get. For 10 features, we get a train error of 90 and a test error of 0.91. For 50, we get a train error of 0.30 and test error as 0.4. For 70, we get 0.1 and 0.5. And again at 100, we get a training error which is very close to 0, but the test error is relatively higher. In a real-world scenario, the test data should be only used after the model is completely fixed. So for that case, we use something called as a validation set, which can either be 20% of the remaining training data, or we can use something called as k-fold cross-validation. In k-fold cross-validation, we use k number of samples from the training data. So just like before, we split the data into two parts, train data and test data. But then, we further split the training data into different parts. Let's say for 4-fold cross-validation, the training data is split into 4 parts. The first part is taken as a validation set, and the remaining part remains as the trained data. In the next step, we again take a new validation set, and the remaining parts become the training data. Like this, we repeat the validations, we keep moving the validation set and take different parts of the training data. This way, we can take the entire training data and yet get a good estimate using the validation set.